In this video, I'm going to solve problem 17 in chapter 12. Hopefully you would agree this sucker's pretty easy. So we have this tire company. They produced a new tire with an estimated mean lifetime mileage of 36,500. Okay, so the mean, 36,500. And let's comma format that. All right. Management also believes that the standard deviation is 5,000 miles and that the tire is normally distributed. Okay, so standard deviation. I just read it, but I can't remember. 5,000 miles. Okay. Make this pretty. Okay, and it's normally distributed. All right, so use an Excel worksheet to simulate the miles obtained for a sample of 500 tires. All right, so this one's going to be easy. Mileage. So you're just, you're going to use that norm.inverse function. So norm.inverse. The probability is generated by the RAND function. The mean, 36,500. Standard deviation, 5,000. And then I want to anchor the mean and the standard deviation. And then I'm going to copy this down approximately 500 times. That's close enough. Okay, hit paste. There we go. All right. Part A, use the Excel count if function, blah, 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 to determine the number of tires that last longer than 40,000. What is your estimate of the percentage of tires that will exceed 40,000? Okay. So first we want the count. So, I'll do this like greater than 40,000. Okay. So count if. All right. So how many of these tires last longer than 40,000 miles? So my range is my mileage. And then again, my criteria is double quotes greater than 40, 1, 2, 3, and double quotes. So I got 157, and then the probability, same thing as before. This is going to be 133 divided by the number of simulations I ran. So take this number, divide that by the count function, highlight my mileage. So I ran 587 simulations. So my probability is about 22%. And again, your probability is going to be close, even if you only did 500, because of law of large numbers. Okay, there is A. B, use the count if to find the number of tires that obtain mileage less than 32,000. Then find the number with less than 30 and the number with less than 28. Well, all right. Seems somewhat repetitive, but what can you do? So I'll do it this way. Less than 32,000, less than 30,000, and less than 28,000. Okay. Now notice they're just asking for the counts, right? Not the percentages. So just going to do a series of count if functions where the range is the mileage, and then the criteria, this first one, double quotes less than 32,000, double quotes, hit OK. Now, because I'm going to do this over and over again, what I'm actually going to do is I'm going to anchor this range, hit, my range for mileage, and then just to make it easier on myself, I'm going to copy this down. Copy, not move. There it is. Now all I have to do is go in here and change these. So this, less than 30,000. Presto. Less than 28,000. All right, there you go. So here's the number of tires that, that last less than 32,000, 30,000, and 28,000. Okay, C. If management would like to advertise a tire mileage guarantee such that approximately no more than 10% of the tires would obtain mileage low enough to qualify for the guarantee, What tire mileage considered in Part B would you recommend for the guarantee? All right. Well, so now I do have to divide. Now I do have to calculate those probabilities. So I'll do the probabilities over here. So once again, I'll take this number and divide it by my count function. Okay, count how many trials. Hit OK. And again, then what I'm going to do is I'm just going to copy this down. So I'm just going to anchor the range in my count function. So I'll put a $sign here and here. Now I can just copy this down. Okay, so managers like to advertise a tire mileage guarantee such that approximately no more than 10% of the tires would obtain mileage low enough to qualify for the guarantee. What tire mileage considered Part B would you recommend for the guarantee? Well, to be safe, I would go with 28,000, right? Because only 5% of those, 5% of all the tires are going to have less than 28,000 miles, right? So you would have to replace the guarantee, right? You have to replace all the tires with less than 20,000 miles. If you go to 30, you're stretching it, because according to my simulation, that's actually over 10%. So I would go to 28,000 miles. All right, and there you go. There is problem 17.